This is P. Srinivasrao. Today we discuss about topics in motion in a straight line. The topics are first one, motion in a straight line, introduction and distance concept, displacement concept, and note points on distance and displacement. To explain these concepts, first of all, we know about kinematics, a branch of physics dealing with the motion without considering its causes is known as kinematics. And in this kinematics, motion in a straight line is a part. And to explain the motion of bodies in this kinematics chapter, one reference is needed. That reference is known as frame of reference in this chapter, and that frame of reference is defined as a system of coordinate axes along with the clock to measure time with which explains the position and motion of object is called a frame of reference. And this frame of references are two types, and that are explained in Newton's laws of motion. And by using this frame of reference, we can explain the position of the body and motion of the body. And now by using this frame of reference, we can explain the rest and motion terms. First one, we know about rest. If the position of a body cannot change with respect to time or surroundings, then the body is said to be at rest. And the other term is motion. If the position of a body changes with respect to time or surroundings, then the body is said to be in motion. And here, with this rest and motion definitions, we have one important point, that is rest and motion are relative terms, because they both are explained by using the frame of reference. For example, we are considering our classroom. Our classroom is at rest when the reference frame is connected to our college or a school. And in the similar way, our classroom is said to be in motion when reference frame is connected to moon. And based on this rest and motion, we can explain the motion of bodies in this motion in a straight line. Or suppose we assume that a body position is changed from one point to another point along a particular path. Then the total length of actual path traversed by the body between initial and final positions is known as distance. In that manner, we can get one more physical quantity, distance. And about this distance, to attempt the conceptual questions, we need some important points related to this distance. And that main points of the distance are, it is dependent on the path followed by the object. And next one, it is scalar, because we cannot indicate the direction while we are explaining the distance physical quantity. And another one is, it is always positive. There may be no chance to get negative or zeros. And next one, its SI unit is meter. If a body travels along a circular path such that arc makes an angle theta at the center of the circle, then to find out the distance traveled by the body, we are using the formula d is equal to r theta. Here r is the radius of the circular path. And by using that above equation, we can find out distance traveled by the body along a circular path. And in this case, theta must be taken in radians. And one more term, that is displacement. and that displacement is obtained by taking the initial and final points, and you can find out the shortest distance between the initial and final positions in a specified direction is known as displacement. In this manner, we can get one more physical quantity to explain this motion of body in kinematics or motion in a straight line. And to solve the theoretical problems about this displacement, we know some main points related to that displacement. That main points are it is not dependent on the path followed by the object. And second one, it is a vector quantity, and it may be positive or negative or zero. And positive means if the position of the body is increased in the direction, then the displacement in that case becomes positive. And negative is obtained if the position of the body is changed in a reverse direction of the direction of the motion of the body, then in that case the displacement is negative. And 0 is possible if the initial and final points are at the same position. And next one, its SI unit is meter. And next one, if a body is traveling along a circular path, to find out the displacement traveled, there is a note point, that is if a body travels along a circular path such that arc makes an angle theta at the center of the circle, then displacement magnitude S is written as S is equal to 2r sin theta by 2. And in this case, r is the radius of the circular path. And note points related to the distance and displacement. First one, if the body is traveling along a curved path, in that case, the magnitude of displacement is always less than the distance. If the body is traveling along a straight line motion, then in that case, the magnitude of displacement is equal to distance. So this is about this session, and in the next session, we can explain the problems on distance and displacement. Thank you.